everyone. Today I'm going to discuss about compiling and execution of a C code. So we are going to see how a C program compiles and executes and what happens internally. So these four processes are involved in the compilation phase of a C programming language. So these processes are pre-processing, compilation, assemble and linking. So all four steps we are going to understand one by one. And we are going to look at the files generated after every step to make it more clear. So first part is these four are basically four stages through which our source code passes in order to finally become an executable. It means from your source code, that is your .c file which you generate initially, that passes with these four stages, and finally your object code or your executable file gets generated, which is basically your machine level instructions. So in order to convert that source code into the executable one, your source code passes into four stages. So we are going to learn four stages one by one. So in the very first stage, what happens is, okay, let's take an example and then we'll talk about the first stage. So first, let's understand this C program. So in the left hand side, this is the code written over here, and in the right hand side, this is only the description, or we have listed out the preprocessor directive. So do not worry about this preprocessor directive right now. Let's focus on the program which is given in the left hand side. So the program is starting with / and asterisk symbol, and it is ending with this. The starting point of the program is now ending with asterisk and /. This means whatever starts with your / and asterisk, it means comments in your C code. Now comments, they provide clarity to a C source code, which allows others to understand your code better. This is only for user understanding. Okay, so this comment section has nothing to do with your program. If you can see, you have written down who is the author of this entire project, who has written the code, the date on which you have written the code, and you can just simply describe what your code is doing over here. So by writing these many statements, you can just providing, you can say, you are allowing other users to understand your code better. Now, if I talk about this program, let's understand these terms. This hash include, what this hash include is doing here, this is including the another file into your file. This include is one of the preprocessor directives in C language. Along with include, I have also used define over here. So there are two preprocessor directives I have used, define and include. These two directives, they have their own functionality. So if I talk about the first one, this include basically it is used to insert the details of another file into the source code. So if I talk about stdio.h, this .h is the extension of the standard input output file. So do not worry about stdio file, what this file is doing over here. Just understand that this include is going to insert the content of this file into your source code, right? So if you want to have a look at this header file, you can simply open this header file comes along with your compiler. So you must have installed compiler on your system. So let's see, you have installed compiler in C drive inside PDM GCC. All right. So if you don't know how to install the compiler on Windows, you can just follow the tutorial which I have provided in the link. So now you can see all the files are given here, which is related to your compiler, and I can search for this header file, because you should know what all files are present in your compiler, at least basic things. So if I open in my editor, you can see the contents over here. So do not worry about the syntax or the contents which is present in the file. We'll talk about stdio.h in the later videos. So right now you should just know that yes, there is a kind of file. This is called .h with the extension .h. It is present somewhere on your system. Okay, this is a part of your compiler. Now, after execution of first step, you are including the contents of this header file into the source code. And by executing the second statement, one by one your program will execute. So after execution of first statement, what happens is you have already seen. Now this hash define is a different preprocessor directive. What this hash define does is, this is also called as a macro, which is a fragment of program that is given a name. For example, if this macro, this something is given a name hello world, it means whenever your program encounters this something, it will be replaced with hello world. Okay, whatever is written over here. So these are not fixed words. You can use any other thing based on the requirement. So right now, just for the sake of simplicity, I have written something in this program. So later on, what will happen? This something will be replaced with hello world in double quotes. So this is what your define is doing over here. This is a macro, and this something will be replaced with hello world. It could be anything, right? It could be any values. So right now it is just used for replacing the content. Now your program starts with this main function. This is called main function in C. This is where your program actually starts executing, right? And then you come across, I'll tell you about int also. Then we talk about printf high. So after execution of this statement, you'll be able to see high on the screen. Okay, so I'll show you the output. And after execution of this statement, you'll be able to print this value. So what value will get printed? So when you write printf, this something will be replaced with hello world, and obviously hello world will be printed, because what you are saying, print hello world. You are not saying print something, because this value is getting replaced. Now at last we are saying return 0. Return 0 means returning something. Just in simple terms, return is basic English term, and here you are returning 0. 0 means 0 is an integer number. That is why here you have written int. Int represents integer. So this means whenever you are done with execution of this program, once this program successfully executes without any error, it will return 0, an integer number, to the operating system, denoting that the program works perfectly. So this is the meaning of this entire code. And now we'll see what happens after the pre-processing phase. So again, let's go back to the PPT and let's see how many stages are involved. So first is pre-processing. Now we'll see what happens if we try to compile this program and what exactly happens after the first step. So we have to copy the code from here. Let's copy it into the editor, paste it, and above this I can include my comment as well. So how to include comment? / asterisk. Let's say this is my first program, and then you write asterisk and /. Now you have to save this file. So Control S, and you can save this file anywhere on your system. So I am saving my file inside C drive, and I've already created a folder called programs, and which is empty. Let's delete this file, and now I want to create a new file. Let's say the name is program.c. So I have saved this file with the name program.c. Now what is the next step? If you can look very carefully, these are my preprocessor directives. This is my main function from where my program actually starts executing. These are the print statements that I'm going to print high onto the screen. And when it encounters something, this something will be replaced by hello world, and finally hello world will be printed. And when everything executes successfully, the value 0 will be returned to the operating system, denoting that the program executes perfectly. All right. Now let's try and understand what happens when we first execute this program and what this preprocessor is doing over here. So now let's see. Now let's understand what is happening. So pre-processing is obviously the very first stage through which your source code passes. Now this is your source code. This is your source code written in .c format, .c extension. Next, what happens after a preprocessor? Once the preprocessor acts on the source code, it will remove all the comments. So all the comments will be removed from the program because it has no importance with regards to your code. All right, this is just for understanding. Next, expansion of macros. Now, what is a macro? Which is defined using hash defined keyword. Okay, so whatever starts with hash define, that will become your macro. So you are going to expand the macro, means you are going to replace this value something with hello world in the entire program. So this is something which is going to happen during this phase. Next, expansion of the included files. So whatever files are included, how you're going to identify? By using include symbol. So whatever you're starting with, a hash include, these files, the content of this file will be included in this source code itself. So stdio.h itself is a header file and content of this file will be added into the program. All right. So all these things are going to happen in the very first stage of compilation and execution of C code. And if you want to see what kind of file will be generated, you have to run this code. So program one, you can write program because my file name is what? My file name is program.c and GCC is my compiler which is going to act on this program.c source code, and after going through pre-processing stage it is going to generate program.i. I will be my new file. This will be my new file which will be generated with the extension .i. All right, and these are additional, you can say, arguments that you have to pass with your GCC compiler. Okay, so these three things are together and these two things are my file names, right? So this is my input file name which you have just provided, and this file will be generated after this pre-processing. And let's see what kind of file will be generated by executing the code. So how you're going to execute the code? You'll have to open the command prompt, and then let me just increase the font size over here. Okay, so now we'll see, currently I am inside C drive and I am inside this folder. But I'll have to go to the folder where my this file is present. So my file exists in C drive. So change the drive. So I am inside C drive and I have to go inside program folder. Programs folder. So programs is the folder inside a C drive. And how I can go to programs folder? This is cd command, change directory. So I've changed my directory and you hit enter. So directory is similar to your folder, so do not get confused. Next is you have to run the program. So we have to we have to just copy and paste this code over here. So you can simply copy and paste your code over here. If there is no problem, a new file must have generated. If you want to see the content of the file, you can simply make use of this command dir to look for all the files and directories which are present inside programs folder. So you'll be able to see there is a file program.c, that was my source code. This is program.c, and after it compiled, after going through pre-processing phase, you can see program.i. That is the intermediate file which is being generated now. Now if you want to check, you can just see inside C drive, go to my folder programs, and this is my source code. This is my intermediate file which is now generated. You can see the difference in the file size as well. Now you open it and check out the difference. If you look at the content, you won't be able to understand all these things. Just scroll down and go to the end part. And let's see what is present over here. If you do the analysis, we can see the comments are now gone. There are no comments because in the compilation phase, we have studied the, in the pre-processing phase, we have studied that comments will be removed. So as you have seen, there are no comments. In program.c, we had one line, one statement, which is now gone. Okay, why this is happening? Because of pre-processing. Now, what is the next step? Expansion of macros. Now we'll have to see. Earlier, where were macros? These are our macros. According to this, something should have been replaced with hello world. Now let's see. So something is now replaced with hello world. As you can see over here. So macro is also expanded. Now we can see if the third part, expansion of included files. Now what are the included files? How you can identify? You can simply say hash include. What files it is going to include in the program? stdio.h. In my intermediate file, can you see any stdio.h hash include this statement? This is gone because the content of that file is already included here. Okay, so now you can show your this file, your source, this particular file is filled with lots of code. Okay, but at the end our code is preserved after the first stage of pre-processing. So I hope this is clear. And this syntax, this program, this entire command is just to see how your pre-processed code looks like. Now, after pre-processing, your next stage is what? This is the same analysis which I have just explained. Next is the compilation. Now what your compiler is going to do is, compiler will act on this file. This is not test.i, now this is become my program.i, and this will convert this program.i into program.s. So now a new file will be generated with the extension .s. Now what this program.s is going to contain, this file is going to contain assembly code. We'll see the difference. Can we move this? Okay. Now run this command. This is program.i, and if I copy this and if I run this code, you will be able to see a new file inside the directory. And the file name is what? This is program.c, the original file. Then this is what? Pre-processed file. And this is my new file, which is also called as assembly code. Okay, assembly file. If you want to see the content, first look where the code is present. Yes, the code exists over here after the second stage. So if you want to explore the content of this file, you can right click and you can edit with Notepad++. So now you can see this is my assembly language code, right? So this code is completely different from what you have written initially. This is my C language code, this is my assembly code. Assembly is a different language which is, you can say, more closer to machine language. Okay, so you won't be able to understand it because it is a little bit difficult. See, push, move, some instructions are there, probably you'll be able to understand. This is my main. Main is what? From where your main function starts, your program actually starts execution. So there's a call, some words are there which you may be familiar with, printf. All right, so this is something happening over here. If you can see in the original code, where you have written printf twice. The same thing is happening over here also. So you are making a call to printf twice. So do not worry about this syntax, it is not required right now. This is just the assembly code which is generated after compilation. Okay, because this code is more closer to machine level instructions. Now finally this code will be converted into the machine code which will be finally understood by your operating system, and then your program will be executed finally. So we'll have to see how this works. So this command, capital S, this tells the compiler and to convert the pre-processed code. The pre-processed code was program.i. This was my pre-processed code. This program is now converted into program.s. Program.s is the extension of the compiled file. So after having created this program.s, we can see the content of this file. Okay. While looking at assembly code, we have already looked at assembly code. They are saying you may note that the assembly code contains a call to the external function printf. Can you see this? There's written call printf, call printf, call main. You'll know the meanings of these terms very soon in the coming lectures. So right now you just need to understand that something like this exists over here. That there is a call to printer. Now what is the meaning? We'll get to know. Do not worry about it. Next, you should just remember that there was something like that in that particular topic. So you just need to remember this part. Now next thing is assembly. Now finally what happens is your program.s, that file which is now generated, is finally converted into machine level instructions, and it will generate an object file. Now what is an object file? The file which is finally generated from the source code. Okay, from the specifically if we say that your assembler will now translate your .s file. .s is your assembly file into the machine level instructions, and this file which is now generated has extension .o. So that extension .o means this is now my executable code, right? So if you want to see the content, if you want to check how the file looks like, you can simply run this particular command. Do the same thing and see the difference. So it is compiled, the process has taken place, and now we can check if we have a new file or not. Now see, a program.o new file exists over here. The same thing is happening here also. Now what all contents are present? Let's explore this file, and the file size is now increased. Now we see such type of file is existing. This is your object file. The extension is .o. So object file is what? That is your final executable code. Now we can say your code is ready to be executed. Now if you have to execute the code, you simply write what? The final name of file. You can write .o also, because this is the final file which I am going to execute now. So if you hit enter, you will be able to see hi hello world. This was something expected from my original program. So this was my original program, and I wanted to see hi and hello world onto the screen. Okay, onto this screen. So I can see now hi and hello over here. There is no space in between these two words. There should be some space. There has to be one new. You can insert a new line also. But right now I'm just making it simpler so that you'll be able to understand it better. So if we can see, if we analyze the whole situation, you have seen that there are, right now I have taught you only 3 steps, all right? So first, pre-processing, compilation and assembly, right? So what happens in pre-processing? You will, all the header file will be included, okay? And you're going to expand the macro, and you're going to strip off the comments. What happens in compilation phase is you are going to convert this compiler, we're going to convert the program into assembly code. Okay, now this assembler will take the assembly code and convert the assembly code into machine level code. And see, the extensions are also written. Extension is .i and .c is my source code extension. So do not worry about .cpp. .h is my header file extension. .s is my the generated assembly code extension. Then finally machine code. This is .o. .o is the object file. It is denoting that the file is now ready to be executed. And the final phase is linking. So I'll discuss about linking phase in my next video. All right. So meanwhile, just think about all these 3 steps and try to execute, follow the tutorial and execute all these steps by your own and see the output. Once you're done with it, then we are going to understand the next steps, that is linking phase. So I hope this part is clear. Thank you so much.